Howdy. So today we're doing chapter 4. So let's jump right into it. Chapter 4, before I get started in the PowerPoint, I really want to look at a couple of key terms, a couple of things that can be confusing out of the book. So the first idea that we're going to be dealing with is formula mass, also known as molecular mass. These are in AMU, atomic mass units. All they are is you take the formula and you get the total, the sum of the atomic masses. A reminder, the atomic masses for each thing is found on our periodic table. So grab a periodic table, and it's these numbers that are right underneath. So 14.01 AMU for each nitrogen on average. Remember, it takes into account their natural abundances. So if I had C5H12O3, I've got 5 carbons, and so I'm just going to do 5 times whatever the mass is for carbon. So I'm going to come over here to my periodic table. 12.01 for carbon. The units on that will be AMU plus 12 times 1.008 AMU for my hydrogen plus 3 times 16.00 AMU for my oxygen. As simple as typing them in. 5 times 12.01 plus 12 plus 1.08 plus 3 times 16. Oh, no. Normal. So quit. Do that again. 120.15. I'm going to call that 120.1 AMU. And I'm just going to keep 4 sig figs. Just keep things nice and simple. And so this would be 1 molecule of C5H12O3. Now, why we use formula mass? Because again, if I had NaCl, it exists as a crystal lattice, but I can look up sodium and chlorine. So sodium is 22.99. I've got 1 of each, and 35.45 for my chlorine. And I'm just grabbing those numbers right off. 22.99 plus 35.45, 58.44 AME. So I've got atomic mass, molecular mass, formula mass. All of those are in AMU, atomic mass units. Now the problem with formula mass and molecular mass is the scale. 1 molecule is too small to really do anything with. In the lab, we usually use mass in grams. So I want to take these formula masses and transfer them over to grams. And so if I change this C5H12O instead of 12.01 AMU, I'm just going to come up here and I'm going to change that to grams. And if I get 58.44 grams of NaCl, now I have a collection of molecules and a collection of formula units here, and so this is referred to as 1 mole. Alright, and it turns out to be an interesting fact that if I have a mole of C5H12O3, it'll be 120.1 grams, and it will be 6.02 times 10 to the 23rd molecules of C5H12O3. And if I have 58.44 grams of NaCl. Since it's ionic, I'm going to say 4 millunits instead of molecules. And so I would have 6.02 times 10 to the 23rd 4 millunits. Ooh, that's long. Let's get an abbreviation. FU. And so we want to use this new idea of a mole. It's a nice, easy conversion. 1 mole of anything is 6.02 times 10 to the 23rd, whatever we're talking about. That sounds really difficult. This number is intimidating. This is Avogadro's number. Abbreviated N subcapital A. Number of Avogadro. You get to memorize Avogadro's number. So Avogadro's number is 6.02 times 10 to the 23rd. I want you to memorize it. But it's not any more difficult than one pair. A pair of whatever is 2 of whatever. A pair of shoes is 2 shoes. A pair of baseballs, 2 baseballs. A pair of roses, 2 roses. 1 dozen, whatever we're talking about, is 12, whatever we're talking about. A dozen roses, 12 roses. Okay? So 1 mole, notice the abbreviation for mole, you just drop the E. Doesn't seem worth it. It is. You're going to write this unit's a lot. Go ahead and get used to leaving off the E. So 1 mole is 6.02 times 10 to the 23rd, whatever. Okay. So what that's done for us is set us up with a couple of conversion factors. We've now, looking at my list, got a couple of things. We've got formula mass, molecular mass. Those are all nice. We'll ask some questions. Not as useful as molar mass. Molar mass translates to the mass of 1 mole. AR at the end means of 1. The molar of 1 mass. Alright, so this will be in units of grams per mole. Formula mass is in AMU. You'll notice when I looked at my periodic table, the units here, there's none listed. That's because you can use them as AMU, or you can look them up directly as grams per mole. So if I need the molar mass of water, it'll be 2 times 1.008 grams per mole plus 1 times 16.00 grams per mole. 18.016 grams per mole. Keep in mind, the number goes with the unit on the top, and it's a 1 for the mole. Okay, so if I needed it for CaCl2, I'd find Ca. Ca is 40.08. See if we can focus. Nope, you'll just have to trust me. 40.08 plus 2 times, and chlorine is 35.45. And we type it in as simple as that. Plus 2 times 5.45, 110.98 grams per mole. So we'll have questions that just say, what is the molar mass of this? We'll also turn around and use these in a lot of conversions. We can use these as conversion factors. So we've already set up then another one, Avogadro's number, And Avogadro's number just uses 1 mole equals 6.02 times 10 to the 23rd. And it's whatever. So this could be atoms or molecules or formula units. Whichever we need to go here. So this leads us to a little bit of an issue of how do we use these. So I'll show a few example problems, but the big kicker for a lot of people turns into being, when do you use them? So if I had 18.3 grams of C3H8 and I want to convert that over, and it says take that to moles of C3H8. And so to use this, I'm making my list, and I'm going to use the molar mass because it's in grams per mole. So setting this up, 18.3 grams. I'm going to use the molar mass. I want grams on the bottom, so they'll cancel out. Moles go here. The 1 went with the moles, and the number that goes down here will be 3 times whatever it is for carbon plus 8 times whatever it is for hydrogen. So looking those numbers up, you'll memorize them quick enough. Don't even have to make you memorize them because I give it to you on the test. You'll be able to look at it. So let's just type that in. 3 times 12.01 plus 8 times 1.008. 43.97. 43.97. That'll get us close enough. So then 18.3 divided by 43.97. That'll be 0.416. Started with 3 sig figs. I'm going to end with 3 sig figs. We'll have moles. Notice the grams canceled out. You'll notice I use grams per mole. This division line is this division line. They're the same. Alright. So then if we had a more complicated one, maybe I had 28 grams of water, and I wanted to know how many molecules of water that is. So this is seems more complicated, but it's really only 2 steps. We're going to go grams to moles using molar mass, and then we're going to use Avogadro's number to go moles to molecules. So I'm going to write this. We could also write it out. 1 times 16.00 plus 2 times 1.008. Did that backwards, it's okay. 18.016 grams per mole. You could write that 18.016 grams equals 1 mole. That's also acceptable. You could then also write 1 mole is 6.02 times 10 to the 23rd molecules of water. Now, when I write these, I'm going to start getting into the habit. You'll notice before I left off C3H8. It's fine because we were always talking about C3H8, but later in the chapter we'll be changing what we're talking about, and so we want to go ahead and get in the habit. 28 grams of water, of adding these labels at the end of the units. This time I'll set it up in a series of fractions, so I want grams of water on the bottom and moles of water on the top using the molar mass. Here I want moles of water on the bottom so they cancel out, and molecules. There's no good abbreviation for molecules. Because if you wrote M-O-L-E-C, looks like moles C. Can't do M-O-L, looks like moles, so gotta write molecules in. Alright, so my 18.016, notice a lot of times the confusion comes in. Where do I put the numbers? 1 goes with moles in everything we've talked about so far. Alright, and so my 28 grams, and then I'm going to divide that by 18.016, because I'm putting that with the grams, just taking it right from here. 6.02 times 10 to the 23rd, that's Avogadro's number. It goes with the molecules. 6.02 times 10 to the 23rd. I recommend you practice saying that over and over with the same cadence. What is Avogadro's number? 6.02 times 10 to the 23rd. Alright, so when we get to type this in, we expect to get something really big because we've got this exponent. So 28 divided by 18.016, and then times 6.02, second EE. Remember, there's no times and there's no 10. That's all built into that E, 23. And I'm going to hit enter, get a big long number. Only need 2 sig figs here, so 9.4. Don't forget the times this E here, times 10 to the 23rd molecules of water. Alright. So one last conversion factor that comes up in this first lab and first set of practice is also this idea of the chemical formula giving you the mole to mole relationship. So when I have H2O, that is telling me that I have 2 atoms of hydrogen to each 1 atom of oxygen. It also tells me that I have 2 moles of hydrogen to each 1 mole of oxygen. It gives me the atom to atom and mole to mole relationships. So if I have C5H12, then I have 5 moles of carbon to 12 moles of hydrogen. Or I could also say for each 1 mole of C5H12, I have 5 moles of carbon. In each 1 mole of C5H12, I have 12 moles of hydrogen. Alright, so trying to figure out which one you need is just going to be based off of the problem, and that's why I said it is so important to get used to writing the things at the end besides just the units. So it's quite common for us to go from grams of one thing to grams of another thing. So we want to be able to use these, and one of the difficulties comes in, how do I know when to use each one? So I'm going to skip through a bunch, and at the very back of our lab book they have this picture as well. And this is our Scary River picture. Now I really recommend that you practice drawing this picture. And this is I call it the Scary River picture, but it's a nice way of organizing your thoughts. And so I'm going to draw a couple of boxes. And so here's my moles of A to moles of B. And up here I'm going to go to the mass of A to the mass of B over here. I'm going to come down to volume of B. And down over here, volume A. Notice it's all symmetrical. Down here I'll have the atoms, molecules, and formula units of A. One big category there. And down here I'll have atoms, molecules, formula units of B. Now, in between these is what I call the scary river. And the only place you ever want to cross is from A to B, moles to moles. Any place else, you're going to get lost. And what it really comes down to is these places are destinations. And they're also found across the top. And so when we wanted to go from mass of something to moles, we used the molar mass. And we found that off the periodic table. Periodic table. That's where we got that. It's in grams per mole. And a great way of keeping up with which one you're going to use, the mass is typically in grams. They might give it to us in kilograms, but we're going to go almost always over to grams. The units for moles are in moles. And so you'll notice that the one in the middle utilizes ones on either side. Going from moles to atoms or molecules or formula units, we used Avogadro's number. Alright. Going from mass to volume, we did that in chapter 1. That was the density. So I'm going to copy over on this side. This will be the molar mass. And this will be the density. And down here will be Avogadro's number. Now, why is this map kind of handy? Well, if you pick where you're starting, you can predict how many steps it's going to be. That'll be these that are given here. And then, or you can go across the top and you'll be able to see exactly where you're going. One of the main things that students do is they try to use Avogadro's number. We make such a big deal out of it. We make you guys memorize it. We talk about it so much. It's so intimidating. Then you try to use it in every problem, but you really only use it when you're going from moles to molecules or atoms, or from atoms or molecules up to moles. Now, the only one I left off here was our most important one. That's our bridge here. I'm going to add that one in here. Here's my bridge, my mole to mole. And I'll remind you that this is given two places. First off, it's the chemical formula. There's that first way across. Now, our second way, we'll learn later, will be the balanced chemical formula. So this chapter is really broken down into a couple of things. Alright, so we've got these conversions. That'll be our first thing we'll deal with. Then we'll come back and we'll learn some concepts. We'll be learning chemical equations and how to balance them, and what they mean, how to use them, how to predict them. And then we'll come back and we'll apply these numbers, these equations, and this math to those same concepts. And it's really going to be about this balanced chemical formula. That should say equation. Balanced chemical equation. Okay, so balanced chemical equation. Let's work an example problem we might see, for instance, out of the pre-lab. It might tell us we've got 25 grams of water, and it asks us to figure out how many atoms of hydrogen that is. And so when I look at my map, one of the first giveaways is these two are not the same. And that's really what you always want to kind of look for. If they're not the same, One's in A and one's B. It doesn't matter which one's A, which one's B, but we've got to cross our scary river. That means we'll have to go moles. We'll have to go through the moles. And so if I pull out my map, a big ugly map here. Alright, so looking at my map, you can also follow over there on a nice easier printout. Alright, so we're starting at mass of A, starting here, and we're trying to go to atoms, but it's of B. So we're going to have to go mass to moles. So I can plan this out right across the top. I'll have grams of my water, and I need moles of my water. We're still in A. So anything that is A will be water. And then the next step will be moles. And it's B, so this is my hydrogen. And the next step needs to be atoms of my hydrogen. What goes on the bottom? You've probably already guessed what we need to cancel out. So grams of water needs to go away. That'll go on the bottom here. Moles of water will be on the bottom here, and moles of hydrogen will be on the bottom there. Alright, now you could refer to this for where to get the info, but we're going to find it anytime you have moles per grams or grams per moles. That's the molar mass, and you find that off the periodic table. So 2 times 1.008 plus 1 times 16.00. That's 18 point. Now, I want to kind of warn us that every place except for the mole to mole, it's of 1 where it says moles. I'm going to go ahead and add those 1 so I don't forget. This 18.016 goes with the grams. 1 goes with the mole there. Atoms to moles, that was Avogadro's number. Alright, now moles in water. So here we're going to be having to use the chemical formula. So the chemical formula is telling me for every 1 mole of water I have, and I'm going to take the subscripts here, and since we're worried about hydrogen, I'm taking that 2. So this 2 came from that subscript. So I'll have 25 times 2 times 6.02 times 10 to the 23rd all over 18.016. We'll type all of this in. 25 times 2 times 6.02 second e 23rd, and then divided by 18.016. 1.7 times 10 to the 24th, and the units left will be atoms of hydrogen. So I used 3 steps, 4 destinations, including where we started. So my map, so this road map really is the key to this. It's kind of planning things out. It's intimidating at first. I get it. Have a road map, get used to seeing it, get used to drawing it out. It helps. Alright, so practice these in the pre-lab, practice these getting ready for the lab, and it's not that difficult. Alright, we'll talk to you next time.